Welcome to Cassandra.Lunch number 135. Don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified every time we post a video or go live. Today, we will be covering a Prometheus-Grafana dashboard for Apache Cassandra 5. Sarma Paidapalli is here giving our talk, and our CEO, Rahul Singh, just joined as well. In this talk, we will discuss how to use open source tools like Prometheus and Grafana for observability for Apache Cassandra 5 and beyond. The co-organizers for this event are Rahul and myself. If you are interested in being a co-organizer, you want to help get speakers or reach out to people in the Cassandra community around the world, drop me an email either through this marketing email or through my personal email that was listed on the previous slide. If you yourself are interested in giving a talk, please reach out for that as well. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is actually made up of a lot of organizations, generally centered around data, and you can find out more about all the various groups at datacommunitydc.org. I know they also have a new URL that is soon to come, DC2. I'm not sure if that's out yet, but it's coming. At Data Engineers Lunch, at Cassandra Lunch, we cover everything from ingress to egress of data, Cassandra monitoring, Cassandra ELT, Cassandra-like databases, anything that works or plays well with Cassandra. If there's anybody new that would like to say hi, what brought you here, or what you hope to get out of this, drop something in the Zoom or YouTube chat. In the YouTube chat. If you are watching on YouTube, which you all are, don't forget to like and subscribe, as well as turn on the notifications so that you can get notified every time we post a video or go live. If you have a question, please ask it. Sarma has indicated that he's happy to take questions during the talk. So if you have a question in the YouTube chat, I'll be forwarding it to him directly. Be polite and courteous to others and share what you know. This is a community. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. We also have a burgeoning LLM and generative AI practice. So if you want to learn more about that or have us implement a solution for you, please reach out. Thanks to all of our sponsors, including DataStax and George Washington University, who provides space for in-person events, which there's actually been some talk recently amongst us about starting some DC in-person events back up. Thank you also to our organizational sponsors. If anyone has job offers or is looking for a job, please drop links and we'll help promote those for you. If anybody has meetups, hackathons, classes, or conferences that they would like to promote, feel free to drop links to those as well. Here is a summary of our events. We're hosting Cassandra Lunches Thursday at noon. If you're interested in giving a talk again, please do reach out to me. We're hosting Data Engineers Lunches on Mondays, and there's actually a third event here, a No-Code Lunch, which we're hosting on Wednesdays, which you can also find on our YouTube channel. All of our Cassandra Lunch videos are available on YouTube. This one you're watching on YouTube there, will also stay available in perpetuity. Check out Cassandra.Link. This is a great resource for all things Cassandra, where we aggregate all of the interesting Cassandra articles that we're reading about. You can also check out a public runbook that we've released and download all of a series of 17 runbooks that we released about the Cassandra ecosystem. Moving back, I think we did those for about a year. With that, I would like to say welcome to our speaker today, Sarma Paidapalli. Please, Sarma, you're ready to go, unless you'd like to jump in and say hi.
I think I have that t-shirt too. Good to see you, Sarma.
Thank you.
Oh, you guys are all representing. Patrick would be proud.
Thank you very much, Nick, for a great introduction. And thank you, Rahul, for hosting us and the meetup, basically. You look good with the new look,
Oh
you know.
yeah, you like it?
Yeah.
Thank
So
you.
I remember John Haddad had that couple of years ago. Uh, so you know me as Oramad in the community. That's my nickname. I'm mad about Oracle, but nowadays I do a lot more Cassandra. I don't want to change it as Cass Mad. You know, it look different. I'm Sarma Paidipalli. I started with databases long back, but notably in 1996, I fell in love with Oracle. I've been managing Oracle databases, very large databases, and well, you know, Oracle gets very expensive and it goes beyond 4 node cluster. So we always poke fun at it, like, you know, Cassandra can run 10,000 nodes and it is open source. Um, I was looking at a lot of relational databases. They were not going anywhere after 20 years. They feel stagnated. They cannot grow beyond what they can do. They're stuck with their core principles of relational model. I fell in love with Cassandra in 2016. I looked at a lot of NoSQL databases. But, you know, obviously, with some of these keen observations, we know the core is so good. I fell in love with Cassandra. um, since then, I've been doing a lot of Cassandra work in the community. I listed my YouTube channel there. Please take a look at it. I usually post a lot of interviews with people. Someday I have to talk to Rahul, uh, maybe this year. Uh, I do post all my open source projects on my GitHub. And also I made like 7 courses so far for Udemy. Udemy is a good platform where it is structured to, you know, train people instead of random videos. It's a very structured course. There are 7 of them I published. I'm working on one admin course right now, but I don't have any details to share yet. Um, so that's pretty much like my introduction. Some of you already know me, but back in 2021, I came to one of the same Apache Cassandra.Lunch meetup, and we talked about the early version of what I'm going to show you today. There are some changes coming in Cassandra 5. So obviously we have to update, rewrite, or fix bugs in the previous Grafana dashboard. So I'll talk about those things today. But this is a great video. I always go back and refer to it, saying, oh, what did we talk on that day? Because historically, we need to know what has changed. Like, you know, if I have to compare today's work. Um, so definitely go back and look at all the other Cassandra.Lunch videos. They're great information. And thank you, Anant, for hosting these events. Let's jump into the new topic here. The topic is old, but we still have to have, whether you run a small cluster of Cassandra or a large cluster, you need to have observability. The main idea is to use open source because Cassandra 5 is coming out. And I have made this dashboard available back in 2020. I did a lot of work during 2020, 21. And I've been keeping up with all the Grafana versions coming out. We need to make sure the compatibility is not lost. So let's talk about the issues with the previous existing dashboards. Mostly whatever dashboards you can find on Grafana website, you see they're old, like from 2018 or 2016. There are 1 or 2 which are more recent ones, but they're targeted for a specific use case. Let's say AWS Cassandra Keyspace or Keyspaces related dashboard is the more recent one. What happens with the old ones is whenever there is a new version of Grafana, some of the widgets go, like, you know, they don't work on the new version of Grafana. So whoever is maintaining these dashboards, they have to go back, make sure the compatibility is there, so they're not broken. Also, one other issue I found was all the existing dashboards, their way of extracting this metrics, they mostly depend on JMX. Um, as we go into the presentation, I'll show you some of the Java code they write is very, very complicated. And for me, I'm not a Java developer, so I want to keep things very simple. So what is the solution I propose is no JMX. I hate JMX. Let's just be very frank about that. No JMX, and if I can keep my Java code very simple, people can understand and they can trust the Java code somebody wrote because you're plugging this Java agent into your production clusters. And it will be good if you can understand what is in that agent. For me, all the existing agents were so complicated that I did not want to go into detail. Always make sure our dashboard is compatible with the latest version of Prometheus and Grafana. I choose Prometheus and Grafana because both are open source, both are community editions are available for free. These are industry standard. Most of you might already have this infrastructure. So bringing Cassandra metrics into this infrastructure will be a easy upgrade for your existing observability infrastructure. Whatever project I work on is I want to keep it simple so people can understand it in plain text. Like I write a lot of bash shell scripts. They're easy to understand with a little bit of learning. Obviously, I use a lot of tools like SED or a lot of Linux tools to just make sure we are able to keep it simple. Efficiency, I'll talk about the metrics efficiency. This is much better than the previous version. So let's talk about how we extract this metrics, and then especially what is the role of JMX. On the right side, I show you what we have in Cassandra, a single node. Cassandra already comes out of the box. We have something called drop wizard metrics. And imagine this is a library or a registry of metrics. And drop wizard is an external package to Cassandra. Cassandra already implements that and embeds it inside Cassandra package. So out of the box, you have the drop wizard metrics registry already publishing all the metrics. And we all know that there is JMX port 7199. If you are thinking about tweaking some of the JMX related settings, I would caution you don't need to touch it. It's secure by default. Out of the box, it is very secure. Don't open remote connections and all, which you are making or breaking the JMX to make it unsecure. So don't mess with JMX settings. That is not required. A lot of agents, what they do is they go through the JMX, go to drop wizard metrics and extract those metrics. And on the left side, I just show you where this drop wizard metrics library or the package is published and how Cassandra project, if you look at the Cassandra source code, how Cassandra project is including the drop wizard metrics in our project. So at this point, we know that there is drop wizard metrics registry and JMX. As I mentioned, I don't like JMX, so let's not worry too much about JMX itself. Now, I will mention when this was added, the metrics reporter config. This is another third-party project which was existing before, and I'll talk about what is the problem with this. So what happened is in the past, this metrics reporter config was an external package which is embedded into Cassandra. This also comes out of the box today along with Cassandra. When you download the tarball, the sample config file also exists with it. So back in 2020, I was doing some research on, let's say, hey, I don't want to use JMX. I don't want to use Java agent. How do I get all the Cassandra metrics out? And I stumbled upon, after reading a lot of documentation, I found that, metrics reporter is by default plugged into Cassandra. So why not use it? And then what I did was I did some research. I put together a sample config, which is also published along with Cassandra software. But what it is a simple YAML file. This configuration file exists in the same folder where you have your Cassandra YAML file. What it tells is every the frequency, let's say, for example, every 900 seconds, take this whitelisted metrics from Cassandra that is obviously coming from the drop wizard metrics registry and dump it into a text file. Now, this text file is a very basic unformatted text file. It has its own formatting, but we have to play, or what you say, we have to extract the metrics in a way we can present it to some other platform like Prometheus. So the Cassandra project always had this metrics reporter config, and all you had to do is very simple configuration to extract the metrics. This doesn't go through JMX. Now, in 2020, I was working with this and I published my finding, but just to give you some more information, in Cassandra 1.1 during April 2012, they added something called Coda Hales metrics library. And then in Cassandra 2.0.2, just after like 1.5 years, October 2023, our favorite Jonathan Ellis worked on this Jira ticket where he included the metrics reporter config into Cassandra project. And then you see in the brackets, I say until Cassandra 5.0 Alpha 1, what happened was this metrics reporter config is not maintained by Cassandra project, right? It's a third-party tool or third-party repo, and we use it in Cassandra project. This metrics reporter config, last commit or changes were done in October 2018, and then repo got archived during 2020. So we, going forward into Cassandra 5, we don't want to use any library which is not maintained and not kept up to date, meaning this library, which is an external library, can have a lot of bugs or some new bugs come in and nobody is fixing them. So we don't want to keep depending on a library which is no longer maintained. So what happened during August, September 2023, our Cassandra project team members, they started looking at the metrics reporter config and they voted to remove it from Cassandra 5.0. Now, December 2023, we got a new release of Cassandra 5 build, which is beta 1. And in beta 1, they removed the metrics reporter config library. So we are not talking about the drop wizard metrics. Drop wizard metrics is still there. We just don't have a mechanism to extract those metrics using this metrics reporter config. So if you look at the history, metrics reporter config was introduced in 2013 and it got removed last year, December 2023. So now what happened was I was on vacation December 24th night. So this is my Christmas present. I've been using metrics reporter config for a while now. You can see at least 3 years I depend on it to get my metrics. 2023 December 24th night, I was just playing with it with the new build, and beta 1 does not support this library. And then I said, what? They removed it. And then I started doing some research, finding all the Jira tickets. I did my digging, and then I said, okay, we have to come up with a new way to extract metrics, and it has to be efficient. So let's talk about what I did during January. So this is an architecture diagram. We can talk about this a little later because this is my original architecture. But a very quick view, this is from February 2021 when I put together this architecture. Cassandra out of the box comes with the metrics reporter config. Once you configure that, metrics are extracted at a given frequency. You can tune that frequency. The metrics are reported or recorded into a text file on each node. And you take the text file using shell script. I transform them and make them look like Prometheus metrics. So now we can provide these metrics to Prometheus or present them to Prometheus. Every Cassandra node will run something called node exporter, which is an agent for Prometheus. And Prometheus can go get those metrics and then present them to Grafana. I also have this Prometheus alert manager. We can use the alert manager to send out any notifications. Let's say there is a node down, Prometheus will see it very quickly, and then it will send out the alerts, paging, and all the emails or anything you want to configure for notifications. This was a little bit previous architecture, so we'll talk about what I did with the new one. Let's talk about the Java agent first. So January, I came back from vacation. I started to reach out to people, say, hey, we don't have this library, and I'm not a Java developer, so I don't know what to do. I'm lost. And one day I was talking to John, my favorite person in Cassandra community. John said, while I was explaining him, he said, oh, the drop wizard metrics is very easy to get into. Here is your 40-line code, which basically extracts all the metrics from drop wizard metrics registry and publish it as an endpoint. Now, what this particular 40-line code does is it efficiently, within less than 2 seconds, it is getting all the metrics and publishing it as a small website. Now, remember that Cassandra has a lot of metrics to publish. It can be anywhere between 20,000 to 60,000 metrics. And it is just too much information to show on any presentation layer. So what I needed to do was, I said, okay, this is very good. This code I can use, but I don't want to publish it as a website because I need to do some more relabeling, because you need to plug in, like, say, which cluster this belongs to, or what is the node, is that in a specific data center. So there are several other labels we have to add to those 20,000 metrics. And then out of those 20,000 metrics, probably 18,000 of them we don't need. So what I did was I went into changing the code. I took the original code written by John and I made it, I did not make it simplified, but basically using the same core engine or the idea. I'm just showing you here, very simple Java code we can read. This is maximum of 60-line code. So what it does is, during Cassandra startup, basically this agent is plugged into Cassandra. During startup, it will register itself to the metrics registry, the drop wizard metrics we talked about earlier. Once the registration is done, it puts one information line into the log file, system log, which says, okay, now I'm able to listen to all the metrics coming out of Cassandra. And once that is done, you see the line 41 here, the top line, which is actually the registration part. It just tries to register itself so I can listen to all the metrics now. Then the Java agent, what it does is basically at a given interval, the interval is published in the previous line number 28. You can see interval is 5 minutes, but we can set it to, let's say, 2 minutes, because I'll show you how efficient this code is. What it does is every 5 minutes, it wakes up, the agent wakes up, takes the metrics from registry and dumps them into a text file. So this particular function is just writing them into the text file. Okay. So since the code is not too long, like 60 lines of code, and it is extremely efficient, I'll try to compare with any other agent we have. So what we have in summary here is, I came up with, when John wrote that code, I tried to modify that code to fit our requirement here. The jar file is just like less than 300 kilobytes of file, 40 lines of actual Java code inside that file. One thing to note here is this new instrumentation code does not work with Java 8 or 1.8. So it is only compatible with Java 11 and Java 17. Cassandra 5, if you're going to use Cassandra 5, don't use it with Java 8. There are a lot of optimizations for Java 11 or Java 17. So obviously this fits into our model where we want to go forward, compile this, the Java agent, which is only 40 to 60 lines of Java code. What it does is basically, as I mentioned, every 5 minutes or 2 minutes, whatever you configure, it can dump like around 20,000 metrics into a text file. Now, what is the advantage here is the metrics we extracted with this Java agent are already in the Prometheus format, meaning we can directly present that to the Prometheus and Prometheus will know what to do with them. So in the right side, the black window, it is showing you the sample metrics, how they look like. So you can see the last line in that metric says the compaction related metric. It says total compactions completed 13, small cluster. I don't have too much there. And the source code is published in my GitHub, so you can take a look at it. But I also have the pre-compiled jar files, which you can download. As I said, 300 kilobytes for download. And you know what is exactly in that Java code. So there is nothing to be worried about, this thing is doing some malicious code. So, well, we need to poke some fun at some existing projects, right? I'm going to have some fun here. MCAC is the metrics collector for Apache Cassandra, has 22 Java files and about 3,800 lines of Java code compared to what we wrote as an agent. Well, now you can decide which project is much better to manage. By the way, MCAC is completely broken. It does not publish what we need. The Grafana dashboard does not work. So obviously, I can maintain my 40 lines better than this. Also, the 40 lines code, why I mentioned that so much is from registry to the file is less than 2 seconds. So to capture 20,000 metrics, it's just taking 2 seconds or less. And that's the efficiency there. And then Prometheus is scraping the whole thing in less than 30 milliseconds. And that is on a small, medium-sized node. But definitely I should do more testing with bigger nodes, bigger cluster, and we'll see what happens after that. So now that we know there is an agent, what I did with this last month was I published a new architecture. I say every Cassandra node will have this Java agent, and the remaining process is same. We have the Prometheus formatted metrics file. We take the text file using shell script. I add some more relabeling to that. Now, I could have chose to do this whole thing in Java, and then Java file becomes like 1,000 lines of code. So we just keep it the same as my previous method is use the shell script, reformat the file, present it to node exporter, and the remaining layers stay same. I will show you some of these metrics. Like, I have started publishing more metrics now because there are some more useful metrics which I was not capturing earlier. And that's where we come into Grafana, say, hey, I can add more metrics, make it more useful. And this is the current state. Obviously, this is work in progress. Let's see. Okay, this is just a slide to show you how different dashboard screens look like. There's a sales pitch. You don't need to look at that. Finally, the code is published on my GitHub. So take a look at it. All the open source developers, they like to get a star on their GitHub. So just go like the project, use it, test it, and give me feedback. So that's the final slide. Congratulations to all catalysts. This was during Cassandra Summit. I have my favorite people in there. I know Rahul for a long time. I've been asking him to meet in person. I live in Virginia, so very close to meet him. Aaron Plutz is a good friend. I worked with some other people, and I communicated with them. Patrick McFadden published this slide during Summit. Unfortunately, I was not there in that Summit. And I am sure I'm saying the name wrong. Katrina. She is also there in the slide, and she is the one who committed that metrics reporter config removal into our Git. So all important people in one slide. Thank you very much for recognizing. And what I do is, that's the presentation part, right? Let's take a break, but I want to show you how the dashboard looks like. So any questions so far?
So there aren't currently any in the chat, but I was wondering, sort of in your experience, just if you could speak to sort of Cassandra 4 versus Cassandra 5, the experience of monitoring it. Are there really any major differences that have jumped out to you from the monitoring perspective?
Okay. So that's a good question. There is a huge jump. We are going from Java 8 to Java 11 or 17. Basically, if you're going to run Cassandra 5, I would say run it with Java 17 because Java 21 is already on the way. With all Cassandra 4, we all have been stuck with Java 8 for a while. There are a lot of improvements which are not there in Java 8. We can take advantage of all those new features. GC has become better. Cassandra has GC pauses. It's a big issue for the entire community. With the newer garbage collection mechanisms, Cassandra is performing much better with newer GC. So just upgrading to Java 17 and Cassandra 5, obviously we can take advantage of Java itself. Now, let's talk about the compactions. So far, I have seen many places we decide, oh, is it size tiered or is it time series, or now we have a new mechanism called unified compaction strategy. So when we decide to just start Cassandra 5 with unified compaction, I don't even have to bother about which type of compaction we should be doing on the table, because it's a very new kind of mechanism where it does size tiered or time series or time window compaction based on the pattern it learns from the data you have. So unified compaction strategy is really good. The shameless plug. There is a dynamic data masking. I made a video on how to use it in Cassandra 5. Dynamic data masking is a wonderful tool where you can hide some of the data for your, let's say, you have a team which does sales and they don't need to see your employee salaries. You can hide the data from sales team. So dynamic data masking is a wonderful tool. Take a look at that, which is coming out on Cassandra 5. For observability, especially since the model itself is changing, what I decided was to using this old method of looking at Cassandra metrics. Sorry, I'm just trying to find the correct slide. So this method is changing. It's gone anyway. And since we are going to write the new agent, I have to do a lot more testing with it. And I welcome people using this on a larger cluster. I have been playing with Cassandra 5 for a while now, since it's Alpha 1. But I would like to get more, let's say, insights from somebody who's running larger clusters. Observability wise, I have not seen any degradation in performance if you have to extract this metrics. At the same time, we have so many other ways of monitoring Cassandra. Now there is a SQL based queries you can write on your what is that called, virtual views or system views. So the metrics are now published as views inside Cassandra, and you can write SQL/sh commands or SQL commands to get those metrics. So overall observability has not changed much, but since the new version of Cassandra and Java 17, I feel like this is a good forward thinking architecture of the whole product. Okay.
I would also add, I think, Surma, the virtual table, the virtual tables that are available for some of this information, may not be all of it. It affords people that want to have some sort of real-time view of what's going on a better way. Of course, this is historical, right? Everything you're putting into Prometheus is historical. But I just wanted to add that I find that pretty cool that some of this information, the configuration, some of the metrics are just, you do a SQL/sh and get it. Huge for me personally. Most people are like, yeah, who cares? But I'm just an SQL, CQL guy, right? So I want to say that SQL/sh thing makes me happy. Instead of doing a JMX call, right?
Yeah, some more fun at JMX. But having that SQL access to metrics is very good when you're debugging an issue, because now you're not going to wait for 5 minutes to show up on Prometheus or Grafana. You can just go live feed into your metrics, which is a wonderful way to look at the metrics.
Yeah, that's really
Okay.
valuable.
Yep.
Thank
Cool.
you.
Oh yeah, no worries.
Yeah, let's dive into the dashboard.
Okay, perfect. So now that there are no more questions, so I hope we like the solution. So this is the working dashboard right now. I am running it on a local. I have four node Cassandra cluster. So some of these things, like let me increase the font. Some of these options are available in Grafana, so I don't have to do anything special. Let's say you want to look at data for like past 12 hours. So you can just switch it. Grafana itself provides this time limitation or time window. So I don't have to do anything special to get this going. There is also an option here to see how frequently you want to refresh your dashboard. This is good for like people who are just on a different screen. They just have your observability window going on. They want to look at how the compactions are happening, how the memory is, or GC is happening. So you can just set it to a specific amount of refresh and leave it there. This is also provided by Grafana. What I did was I wanted to use the same dashboard for many clusters. Even though I just have one cluster here, you can select the clusters. You can monitor your multiple clusters, different versions, because it's just one single pane of glass for all your Cassandra metrics. Once you select the cluster, you can also drill down into, like, if you have multiple data centers, then you can choose the data center. Here, I just selected all data centers. You can also drill down into the host names, a specific host name you can pick up, or even the key spaces or table level. So you can drill down, and if you're monitoring a specific key space, this is very useful. You don't have to show all the key spaces on screen. Remember one thing, that Grafana itself is pulling data from Prometheus using GraphQL or PromQL. You don't want to take a lot of data and then throw away 80% of data. So this fits into your select model, where you select only what you need from the database. And that's what Grafana does in the background when you do these filters. Let me just decrease the font size here. I have couple of sections. One is the system metrics. These are all plugged into the same dashboard, so you can see your system performing. I have a very high usage of CPU, very bad. But I have 4 nodes. They've been running for a while. And this gives me a very quick view on how my RAM usage is. This is the current snapshot. And then there is a storage. I saw that many places, when we are writing a lot of data to Cassandra, you can run out of inodes on Linux, and I wanted to put that metric on the screen. Probably I should change the gauge to something else, but for now, this shows a good view of how our storage is doing. If you have multiple mount points, it will show all those. Right now, I have only one mount point. Then I have system CPU and RAM usage. As I mentioned, my CPU is like 100% on some of these nodes, so they're small VMs. So, but you can see a nice view of historical view here. Then let's jump into the Cassandra metrics. So the first 3 tabs are just for system metrics, and then I have Cassandra metrics. So this is a very simple view of how many nodes are in this cluster, who are running, what's down and what's up. Like, we can have one node down and it will indicate it here. And remember, Prometheus has our alert manager, which can send out alerts. So this is a view where you can tell how many nodes are there. And the summary, just like the system summary, this is a Cassandra summary, which shows all the different nodes running. Now, remember, you could be running 3 nodes with a different version during updates, upgrades, or updates. During that time, you can see which node is running the older version, which node is running new version, and it just helps to look in one place to see what is your cluster looks like. I have a memory tab here, this is the Cassandra memory, the heap. I really like this view, because what you can do is, let's say, for example, I pick one node, let's say, okay. So you can see how this Java heap starts from 0 or very less. and it goes up slowly. And you can see between 10 and 10:30, that's when the garbage collection happened, GC. So imagine that GC window is like 10 seconds, then you should be worried because we have to tune our GC, or we have to give it more heap so that Cassandra is not doing so many GC or garbage collections. The reason we talk about this a lot is GC pauses, right? So if you had every 10 seconds there is a GC pause, your cluster is actually suffering with a lot of garbage collection. So this is a very good view on the garbage collection window. Now, one other thing is with Grafana, what I noticed is once you filter it to one node, I don't know how to put all the nodes back. So I had to just do a reload. Somebody, if you know how to do this, let me know. So the issue I mentioned here is like, once you go in here, you see all the nodes. I click on one of them and it takes away everything else. I don't know how to put back the other nodes into the view. And then I also have a text view where it shows what is the heap. We should configure all our mem tables to go off heap. That way you get more performance. You should store mem tables on off heap or off heap objects, let's say. A little bit more on a couple of things I'll skip here. Let's say query language. This is a very good view of how your application is working. I have a Python application which is writing data right now. And you can see the prepared statements versus unprepared. I have seen many clusters where application just comes and does something notorious. They don't prepare their statements and the performance is like all wasted. It spends a lot of CPU time to parse those statements on the fly. And here it clearly tells you that we have 26 prepared statements and they're cached. Now they run like 100,000 times, and some of the clusters may be millions of times. So it's always better to have prepared statements. And I do have some 20% of them are unprepared statements. I don't know. I have to check what they are. That's the curiosity factor. Like as soon as you see this, say, oh, what are those unprepared statements? Anyway, there are some more tabs here. Interesting ones are like client authentication metrics. If you had failures, like 10 of those are failures, then you have to be worried like somebody using a wrong password, or we have to just check what's happening. And I try to put the hints also in the same screen where you can find out if there were hints which are stored. And if there is nothing to send, obviously the stored number will not become 0 because this is how many hints are stored since the node restarted. Once you restart the node, this number becomes 0 and then it starts going up again. All the metrics are like that. They basically start at 0 whenever the node is restarted. Some more stuff like client request time.
Follow-up about that point, Sarma.
Mhm.
Is there any system level tracking of like how many times a node gets restarted?
Oh, that's an interesting thing. I did not think about that, but I think somewhere I should build out a small metric which says how frequently a node has restarted, right?
Yeah.
Similar to the memory we have here. That's a good idea, actually. I'll think of it. Right now, I don't think that kind of metric exists because Cassandra will reset all the metrics to 0 as soon as it restarts on that node. But since we are using Prometheus, we have that knowledge. Prometheus stores all those historical events, and we can pull that metric and say, this is how frequently you're restarting your nodes. There are organizations where they restart nodes every night. Like they'll pick like 4 nodes, they'll restart every night. They come from the old operating system. They don't like systems running for long, I have Linux servers running for 6 years. We haven't restarted them.
There's different reasons, I think, like, people need to restart it. Sometimes it's a periodic patching, operating system level patching, those type of things. So, I mean, I think it's a subjective thing to see if they've been restarted. Although I'm with you, that old mentality. There's a project that I've been consulting on for seems like forever, but there's cron jobs that basically check to see if a node is down and it restarts. So we know exactly how often they're restarting. So anyway, sorry to interrupt. Go ahead.
No, that's a great point, right? And that gives me a good idea, Nick. I'll work on once I have this stabilized, I will definitely add one more metric which says how frequently your nodes are restarting, because that metric is already captured into Prometheus now. Every time a node is down, I have a metric here which shows how many nodes are down, but also I know which node is down. I'm not showing it here, but what happens is let me do a small. Live demos are always good. It's fun to do this. So let me just go here on the second node. I'm just going to say admin stop. Okay, so I initiated a stop on one of the nodes, and we'll just continue to look at dashboard. It will show up here. Okay, so there are few more metrics I can show you which are really interesting. Is the client request timeouts. Any timeouts will show up here. Then we have to dig through why they're timing out. I do have a small graph here which shows which key spaces are growing and at what rate. So you can see, for example, if you change this view to 2 days, let's say, you can see how frequently this thing is increasing. How much data you're writing. It depends on how many millions of transactions we do. It depends on the transaction rate. I have the same metric for the table level, where it shows which tables are frequently written to and how are their sizes. So that tells you which table is more active on the cluster. And definitely what we can do is to just go table level. Like we can do a filter, like say, for example, I want to look at only sales orders, let's say. And then I just apply that filter, and you can see this filter got applied immediately. So that's the good part of having Grafana handle the more of these queries. If you go to GitHub and get the dashboard right now, you will not see these compaction related metrics. These are new. I'm still working on them. This version, dashboard version, is 2.5 for January. I will wait for some more time before I publish this because I'm still finding small bugs here and there. But this tells us how the compaction, how it is doing. I'm actually having an idea of also I should include a graph which shows how your compactions are doing, because sometimes if your cluster is suffering with compactions, I do have a situation where cluster is big, but 70-80% it is just doing compactions. And when the compactions are non-stop, what is happening is we have write timeouts, there are drop messages, all other things are happening over there. So let's go back here and see if my node down shows up. And since the node down is there, if I had alert manager, it would already send out alert. But also, I want to show you this view where the specific server shows in red color. So that way you know which server is down. That's the dashboard, and pretty much that's what I wanted to present today. Let me know if you have questions.
Yeah, so this stuff is really cool, Terma, and I remember when I first started working with Cassandra, and Op Center was kind of the only game in town, with the original Op Center being open source and it could work with Cassandra. And still to this day, I look at certain Op Centers to see what's happening. One of the things that Op Center didn't give me, and this doesn't give, is when I'm trying to understand core systemic issues as it relates to data model, where you have to really pay attention to the table stats. And the table stats are like 30, 40 different metrics for a table on a node at any given time, right? And I think you may be using some of that information for your table sizes, right? And it's really hard to visualize that. In fact, from my own perspective, just imagining all of that data, like just doing it in Op Center, you have to like go to each metric and say, okay, show this to me in a graph, show this to me in a graph, show this to me in a graph. Especially if you have 100 nodes, you can only look at 1 or 2 metrics, and you have to. So Grafana gives us a much better tool to kind of toggle between key spaces, tables, and everything. But still, there's this like 30, 40 things happening across as many nodes as you have it. And I think Grafana has the ability to do it, but from my perspective, it's like I use the same kind of like key value structure for the shell, for the text file, and I pivot that into a Excel file, and I use conditional formatting just for that, just in time. Like, show me the skew, right? Show me the skew for the reads, the writes, the key, the number of keys, and things like that. I'm wondering if that's something that you feel is like important enough to put into something like this, or is that something that's more like, okay, we just have to go dig deeper when there's a problem?
Yeah, so I know you did a lot of work, and it is available through Cassandra.Link from Anant's website. The tool is good. Here is my balance between like an observability, right? So for example, this kind of Grafana is very good when you're looking at some specific thing. Like most of my time I spend looking at the memory, this one, because over the period of time, you can see very clearly. Now, when you want to drill down into specific issues, I think that's where your knowledge and expertise comes in. And you cannot really present it in a graph mode. You just have to get into character mode, hands dirty, run some tools. And especially the tool you built basically takes the same metrics, present them in a different format. And that is only suitable for debugging,
Yeah. Absolutely.
And what happens is the balance I was talking about. So I told you, right, out of the box, we publish like 20,000 metrics. And imagine all that consumption when you come to pick it up from Prometheus. It just takes a long time to scrape those metrics. And then your nodes, obviously, I have only 4 nodes here. In your organization, you might have to have the same Prometheus go to like, I don't know, maybe 2,000 nodes, right? Different clusters, different nodes. So we have to strike a fine balance between how many metrics we want to see on Grafana, and definitely have those tools handy, which operator or administrator can run on the server. And we can definitely leverage some of those metrics, bring them into Grafana. So as I said, Rahul, I need help with even Grafana has issues. Like I don't know how to present some of these things properly. So there is learning involved.
Yeah, I think Grafana gives you a toolkit, and you have to work within those bounds, right?
Right.
In fact, I mean, I put that project down for a little while because I was seeing the promise of the virtual tables.
Mm-hmm.
And I was like, okay, once the data is here, we don't have to do anything about, scraping the table stats into key values and pivoting it and all that stuff, right? So I'm like now ready to maybe tackle that problem again. But again, Grafana is like its own SDK, its own framework, and you have certain, constraints of what you can and can't do. Before Prometheus and Grafana was a big deal in the Cassandra community, I was aware of it. And initially when I looked at Kibana and Grafana, it still wasn't doing that kind of like view. So I was thinking about using like just a React grid and doing some type of thing. But maybe it's there now. So it's worth investigating from my perspective to see if you could even attempt to do that. But like all things open source, you have to kind of take it as it comes and maybe extend it and do some more work.
Yeah, that's true. Just since we are talking about this topic here, I want to actually, I do have some sales data. Let's say my Python code is generating sales. So imagine somebody is buying stuff nonstop, right? My Cassandra tables have that data. I would like to actually bring that into Grafana without using Prometheus. So just publish it to Grafana and say, hey, this is how your sales are happening. And you could use the same thing for many things. Like say, for example, you're capturing sensor data, right? And you want to just have a current snapshot of all the CPU, how much hot they're running. So you just want to show your Cassandra data in Grafana. There is a project out there, but it has to have a specific time series kind of data. But what if my data is not time series, right? So I definitely want a Grafana plugin for Cassandra. So Grafana can directly go run a SQLSH command or SQL command and then show the data in a graph. I'm going to play with Prometheus because we can definitely plug those metrics through Prometheus and bring them to Grafana. I will come back and present that couple of months from now. Cool.
Awesome.
Very cool. We do have one question from the chat.
Okay.
So I think this is a sort of like Op Center comparison. Are the number of read-write requests available as a data source?
Yeah, so that metric is available. It's just the way we calculate from Cassandra metrics, right? Sometimes there is documentation missing. So we don't know what that metric is. I'm trying to look at all the existing dashboards just to see how they're calculating the metric. That formula is so complicated. I have not figured out how to show it here yet. So we'll work on it.
Rahul, do you have any other questions?
No, thank you for hopping on and continuing to contribute to the community. It's things like this that make our jobs easier as operators. And so thank you again for joining us, but definitely thank you for continuing to work on this project.
And thank you for hosting this and all the events we do. Rahul, I need to sit with you for a candidate interview.
Sure.
And if we can do it in person in DC area,
yes,
it would be wonderful.
Let's do it. And I was going to say, when we bring back the in-person events, I'm putting you on the spot. You're gonna do the first in-person talk back after the pandemic, right? Yeah. Okay. Cool.
Okay. We'll do.
All right, we're good to go then.
Oh, by the way, one small mention. Remember a couple of months ago, you talked about how we can do a nice backup. And you mentioned this, and I learned a lot from that. Is you have a 3-node data center, but you create 1-node backup data center, and that's what I use here. I don't know if you noticed.
Awesome.
So
yeah,
that's my
data centers.
yeah, that's
awesome.
That's my backup data center. And if people did not see this talk, this is one of the Cassandra.Lunch on how to do backups by Rahul. How to do Cassandra backups efficiently. So
I won't take credit for it, as in I didn't come up with the idea. It's something I saw on not just one, but 2 clients. And I was like, there's something interesting here, and it just makes more sense to me as the more we use it. So glad you could learn something from me, but it didn't come from me. So
but one thing I want to plug there, right? I just sat in a paid conversation with a vendor, and they're doing dedupe from Cassandra. So I can imagine how they're doing dedupe. This is the method. They take the backup of the dedupe data. So, but I'm not mentioning the vendor here, but that's all good, right? Yeah, cool.
Sarma, thank you so much for being here. To our great audience, thank you for being here and participating. And we'll see you next time.
Thanks so much, Sarma. Thanks again, Nick.
Bye, everybody.
Bye.